Welcome everyone to this webinar. Thank you very much for being here. This is going to be part one of a two-part webinar. The first part of this webinar today is an overview of artificial intelligence from the auditor's standpoint. We're going to talk a little bit about what AI is and what elements make up AI, the different types of AI and things like that that are important to have that overview, so to speak, before launching out and actually auditing it. And then in part two, we'll cover more specifics about how to audit AI systems, the approach, and things like that. So my name is Warren Alford. I'm located right outside of Tampa. My background is in Department of Defense contracting and aviation. I hold quite a few certifications. I'm also an accredited CISA instructor, and I work with Dennis in delivering the CISA prep course. I'm also an ANAB contract lead assessor, and my company, ALS Cyber, delivers a lot of different services, all centered around information systems, assessment, auditing, and things like that. So again, this presentation is going to cover what the auditor needs to know. So what is AI? We hear, a lot of AI language. We hear a lot of buzzwords, but from an auditor standpoint, what is it and what do we need to know about it before we actually start auditing it? And then also we're going to take a look at the AI life cycle and start kind of getting ready for part two, which will come at a later date for actually auditing AI. So AI is, right now, it's the buzz term that's out there. Artificial intelligence. It's basically, the definition of it is development of computer system that can perform tasks typically requiring human intelligence. And that's the whole point of AI. Business leaders are very interested in this technology. They're starting to develop it and roll it out. They see what the capabilities of AI are, and they're putting their money where their mouth is, so to speak. Generative AI startups have raised over 100 billion with a B dollars, and we're expecting that amount to almost double this year. A lot of money, a lot of infrastructure being put in place to support these systems. Businesses are starting to tie these AI systems together, and in some cases, creating their own ecosystems using AI as the backbone. They're very complex systems, as you can imagine. They utilize natural language processing, large language models, recurrent neural networks. All these are terms that you may have heard of, and we'll cover what they are a little bit more in depth. These systems today are not infallible. So one thing to keep in mind is that AI is really in the infancy of its development. While some companies claim to have mature AI models, in theory, maybe, but in practice, not quite yet. there are still a lot of things that are going on, and a lot of development is needed. AI does make mistakes. It takes liberties. It does what we call hallucinate. It is wanting to give you an answer, and if it doesn't know what the answer is, or it can't put that information together for you, it starts making it up as it goes in some cases, and we've seen that with ChatGPT and different models out there. Again, it's in its infancy, and it's considered to be kind of a novelty tool right now, but it's going to develop into a real solid foundation in the future. There are some skills that are needed to audit AI, and there's really a shortage of information out there about how to approach AI auditing, as well as the resources being very scarce right now. There are not a lot of auditors that consider themselves competent in this field, and that's kind of what we're doing today, is hopefully opening that door to the possibilities for you to audit in the future. And lastly, on this slide, AI has ethical principles that are still being developed. So the ethical application of AI is going to be very important. Also, taking out some of the biases that are going to be inherently included in these models based on the company or the organization's belief systems and things like that. We have actually seen in the wild where some of these systems being developed right now have a certain outlook on the world, and all of the responses are pretty much geared to reinforce that. And we kind of consider that to be the poison well model. So again, it's very new. It's going to be something that is utilized in almost every business. I can't see where there is not a use case in any business or organization. And in the future, I'm sure there will be even more use cases. We'll take a look at some of the government use cases that are coming up right now and have come up in the last year. So AI is really the ability of the software itself to take on more of a cognitive approach to things. It has been compared to human learning and human development, the way that the human mind works and the way the brain and the neural inputs all come together to formulate ideas and to basically deliver solutions to problems. This includes capabilities for understanding natural language. So language is the interface that we see between the human and the actual AI model. And again, it's becoming more integral to our lives. We see it on streaming platforms. We see it in medical applications. And it's really enhancing productivity across the board. Some of the earliest forms of AI is represented here. You may remember the Office Assistant that was in Word and different software programs. This is really the first example of AI that's out there. DARPA has actually defined 3 waves of artificial intelligence. We are actually in the second wave of development of AI. The first one started with basic frameworks. So this is expert knowledge that has been put into the AI model. It has certain parameters and it remains within the parameters. And this can go from a handheld calculator all the way up to, in this example, online tax preparation. So again, it's dealing with parameters and it remains within the parameters. Many times a developer has actually limited the inputs into the source fields, so it will only accept certain inputs and it will only deliver certain outputs based on its knowledge. Using machine learning is actually the training of the algorithm. So once that knowledge is put in, if it has the capability for machine learning, which is the second wave, then it will start to learn from the inputs. Again, going back to an example of ChatGPT, where you can give it a thumbs up or a thumbs down for the response, it's actually learning from that as it goes through. That second wave, an example of that will be facial recognition technology. This wave is more based on statistical learning and machine learning, and it integrates the natural language processing, the computer vision, and some other parts of it that we'll talk about. And then the third wave, as defined by DARPA, is the contextual application. So this is it takes really the first and second wave and it builds on that to be more sophisticated and to really act more as a human mind would. So an example of this is autonomous ships or autonomous weapon systems that would be able to acquire a target, recognize that target as being a friend or foe, and then acting on that, and then following up as things actually develop in real time. So right now we're in that second wave. Some AI types, we have machine vision, and this gives the machine the ability to be able to see. And this takes the image or images and it breaks it down into digital bits and bytes. And then it's able to use that information inside the model. So facial recognition, vehicles being able to see and recognize certain objects. That's an example of that as well. Then we have augmented intelligence, which uses a little bit of the input from a human and it picks that information up and it helps to actually, I guess, augment what a human is doing. So some examples of this are some of the robotic AI applications that we see out there now. Artificial intelligence, true AI is really supposed to mimic the way that the human brain operates and provide the ability to understand and comprehend and then correlate certain bits of information from its basic input and from the information from the machine learning that has been put into the machine. So, and then conversational AI, this combines the natural language so that it can understand and process and generate responses. We see certain programs like Siri and Google, Hey Google, and things like that that would allow this to actually happen. There are other AI types: reactive, limited memory, theory of mind, and self-aware. So the reactive machines are the systems that have no memory, and they have very specific tasks, and they always deliver the same output. So an example of this might be a handheld calculator. So it has parameters. It knows what the different algorithms are, and it's just basically putting those algorithms in as you type in numbers, and it delivers the same output. So 2 plus 2 is going to be 4, no matter how often you put that in, or no matter who is actually putting that in as well. Limited memory is something that will take the machine learning, and it uses historical and pre-programmed data, and it kind of puts those two together. It still does not have the theory of the mind, so to speak, but it can lead to some determinations. Like, for instance, you probably saw AI playing chess. And so that would be an example of where it has certain parameters set up, but it does have the ability to think, although a limited capacity, to kind of figure out what the next move would be and what the next 3 or 4 moves might be, as well as what the person that they are playing actually might do. The theory of mind is just the ability of the agent to actually take knowledge and intents of other agents and to use that. So whether that is human interaction and inputs, or a human correcting it, or adding the language part of it. And then self-aware is the ability of the system to actually, what they say, possess consciousness or self-perception. So being aware of itself and its surroundings. Large language models are the very large deep learning modules. And these are the models that take a huge amount of information, and they pre-train the model. So this is done during the development of the AI software itself. The underlying transformer is a set of neural networks, and we'll talk about what those neural networks are. They actually consist of encoder and decoders for that define their capability. The encoder and decoder extract meaning from the text or language, and it understands the relationship between the words and the phrases itself, and it puts it into a communication medium that the AI model can actually use. Sometimes this is from what they call categories. So it's taking certain information in the way that it's delivered it, and it's looking through the different categories of information to make sense of what has been entered, and then it will begin to process that. Unlike the recurrent neural networks that sequentially process inputs, transformers actually process the entire sequence in parallel. So as it's actually happening, it really does not rely on a linear progression. It actually does this all at one time. The transformer neural network architecture allows the use of the very large models, and sometimes these have billions, if not trillions, of parameters. Examples of the machine learning applications are like spam detection, recommendation systems, fraud detection, and predictive maintenance. The
Warren,
machine, yeah, go ahead.
speaking of large learning, LLMs here, we have, it's interesting to note the implications of using those models and how different companies are going with one model over another. I mean, we see Google Gemini being widely used. Some of these are open source. They can be incorporated directly into a company's infrastructure, and some of these are only accessible through APIs. I mean, we're using Zoom right now. Zoom uses the Claude 2 LLM, and that's only accessible through an API, though it does allow for some customization. And we see, Gemini being Google's primary LLM. Usually that's an evolution from Bard, and then they have Palm 2, which they have incorporated into Google Docs and Gmail, their main software as a service applications. I think it's interesting to see that a lot of these with AI, it's very closely tied to the cloud, which was our topic for our last series. These models are hosted in the cloud often because of the scale that's needed and the elasticity, the ability to adapt to different queries and to adapt to use cases dynamically as they're presented. So we see a uptick in cloud hosting for these LLMs, with Google Cloud, AWS, and Azure being the primary service providers, with I think AWS being the major market holder for the LLM hosting. So I guess that's a little closely tied. What do you think about that?
Yeah, absolutely. I think that we are going to continue to see all of these companies produce their own version of these LLMs, and in some cases, with those all working together. In other words, building those as a self-contained ecosystem. A lot of companies are doing that right now as well.
Yeah.
Yeah, go
And
ahead.
I mean, most companies don't have the resources, the budget to create their own large language model, but they'll hire or they'll incorporate. For example, Zoom incorporates Claude 2 as their large language model, so you can use the Zoom Assistant, the Zoom AI, which is really just an extension of that Claude 2 with some customization, and that's really the big business for these LLM developers, to be resellers, to allow other companies to have AI capabilities, whether that's with a chatbot. We see that a lot of times. And you mentioned chatbots. We see Vicuna being one of those major chatbot providers. Of course, Gemini, ChatGPT-4 can also be used for that. And there's other, as you mentioned, the other applications. We even have AI prompts to images, and we have prompts to video now. You can provide a prompt to an AI to create a whole video with parameters. It could be, hey, two people on a train going through a city, and the AI will create an entire video. It's all notional, just based on that prompt. Anyway, I guess I'm going off into a tangent here.
Yeah, absolutely. A good point of that is what we see on YouTube now. We see a lot of videos that are produced 100% with AI. It writes the script, it puts the whole thing together, it creates the video, and it does the narration and everything as well. So yeah, it's already being widely used And an interesting point that you brought up is you have to know where it's being hosted. If you're hosting it yourself on your infrastructure, your system, without any outside communication of the model, that is more secure than dropping your information into an external AI environment. And this is something that will probably, I'm sure it's already starting to affect the defense industrial base. Companies have been using this to generate proposals. And so they drop the information into these external systems and build their proposal. And obviously that information is now kept by the model. And in some of these contracts, that information becomes controlled unclassified information in retrospect after the award of the contract. So a good point there to kind of be aware of where is the model. Do you have the ability to know where all of that information is going and where it's going to be controlled after the fact? So good point.
Absolutely. And even, some organizations are even using AI to help write their policy. And we see this. I've seen companies take ChatGPT prompts and use that to create their own policy internal to try and become compliant with SOC or CMMC. And that can cause issues as well as ChatGPT or some of these other, the OpenAI large language model, or OpenAI as a developer, Google with their Gemini. Those models are great for smaller tests, but whenever companies start cutting corners, writing documents for compliance, using these AI tools, first off, as auditors, you can identify that usually fairly quickly, but it also could introduce some terminology that that might make that company legally bound to their policy in ways that they weren't expecting. That's something to consider as well.
Absolutely. Absolutely. There are a lot of far-reaching and I guess when you look at the ethics and the governance and the compliance of certain things, we're still in the infancy, and the compliance piece of it, the regulation piece of it is being created even as we speak. And so right now, in some cases, it's the Wild West out there. And, it's an exciting time, but it's also a dangerous time in the fact that, companies are pushing the boundaries, so to speak, of what what AI will do. And again, it can be good, and it can also be dangerous at the same time. Deep learning is a subset of machine learning, and it uses the neural networks with multiple layers to basically build a complex structure. So the neural networks themselves are like what they call nodes, or they refer to them as neurons. And these are the things that make the connection for the response, so to speak. So it takes categories and it runs it through this system of nodes, and it begins to understand like the language. So an example of that would be language translation. And so it would go from actual words to adding grammar, what is correct and not correct for the grammar. And then what does that mean for the actual model? So that's what we're talking about. And it's actually modeled after the human brain and the way that the brain um, processes data and how it maps data and how it learns from mistakes and so that's kind of what it's mimicking. And ultimately, when we get to the third wave, as we saw before, we get to the third wave of AI, it will be mimicking the human brain, and not only mimicking it, but actually being a brain itself, where it will learn and have new thoughts and new ways that it can solve problems. So deep learning is one of the things that actually drives a lot of the development, like object detection, facial recognition, self-driving cars, and things like that as well. So a comparison between machine learning and deep learning is fairly straightforward. In our example, we see that we have inputs, and in machine learning, it just extracts the feature of the input, and then it makes a classification, and it does its computation, or its, whatever it's designed to do, and then it formulates and gives an output. The difference between the machine learning and the deep learning is that the deep learning takes the feature extraction and combines that with the classification, and it does it all at once. And it's really not limited to a certain algorithm or a certain way that those neurons fit together. In other words, it can do its own classification. It will take those inputs, turn it into what it thinks that interpretation is, and it will continue to do that over and over again in the classification. And of course, it does it super fast to actually provide the output to that. So again, image recognition, the language recognition, the autonomous systems and things like that are all taking this deep learning. Dennis, you have anything to add on this?
Yeah, within cybersecurity, I mean, as cybersecurity practitioners, we use deep learning with a lot of our security appliances. A good example of this is we have SEM, Information Event Management, Security Information Event Management. We also have SOAR, Automation Technologies, Security Automation Orchestration Response, or Orchestration Automation Response. And with a SOAR playbook, for example, it's very similar to deep learning. That SOAR playbook would learn, or the SEM device even would learn, a steady state, what a normal operating environment for your network would look like. And then from that, start with heuristic analysis, develop or understanding of what would constitute abnormal behavior to help identify malware. And then we can go a step further with the SOAR, either as an add-on like Splunk with Splunk Phantom, or as a standalone device to automate our responses to the net detected malware. Just an example of a way deep learning is already incorporated within the cybersecurity field. So it's a natural use case for AI, because you're analyzing a complex system, the network environment, network traffic with however many number of devices you have on your network, the ports and protocols, they're communicating, the different type of traffic you're going to see on your network. So it takes a robust thought process, a robust AI approach to understand that fully and then detect any potential changes which could be an indicator of malicious activity. So just an example, as cybersecurity professionals, we're already accustomed with AI, more so than I think other industries that don't have this technology. They don't work with this technology on a day-to-day basis. So now it's becoming very surprising for many industries, and industries are developing new ideas on how they can use this AI, when in cybersecurity, we've already had this incorporated into a lot of our security appliances for decades.
Absolutely. A good point. Good point. So this kind of shows what we've talked about in the last few slides, and it kind of puts it together. You can see where artificial intelligence is the overall system, and then you've got the elements of it, machine learning, which is supervised, unsupervised, and reinforced. And we'll talk a little bit about weak and strong AI as well. Then we have deep learning, and this kind of shows how it all fits together. So we have narrow AI. This is also known as weak AI, and it's designed for a specific task. Again, there's not really any learning or cognitive capability involved in this. Weak AI can simulate cognitive functions, but it really doesn't have any awareness, so to speak. And then you have general AI or strong AI, and it aims to possess a human-like ability. So it really wants to replicate the human mind. And right now, it is really a theoretical concept, but as things improve over time, the objective would be for this technology to be able to think like a human and make those decisions and course correct itself as it's doing certain things in a very broad spectrum. So natural language processing is just a branch of AI, and it focuses on the interaction between the computer and the human. And it is actually what allows the human to communicate with AI, and then allows AI to communicate back to the human. So computer vision is a part of AI. It's the field that enables machines to interpret and understand visual information from the real world. We see this on vehicles, autonomous vehicles. We see it as facial recognition, medical imaging, also surveillance systems that actually have activity recognition built into them. So we have three layers of this. We have the image recognition, which is just the image itself. We have object detection, which is pre-programmed, and then the ability to learn about what an object is and how it interacts with its environment and with the AI itself. And then we have image segmentation, which takes an overall larger image and breaks it down into smaller pieces. Example of this would be geolocations, geospatial imaging, maps, and things like that.
Yeah, Warren, one thing that we use often as security analysts, when it comes to, we mentioned facial recognition, we also have for access control gait analysis, where a AI system will be able to keep track of and develop a pattern for how individuals, how they walk, the pattern of their walking, cadence of their footsteps, their body position, and from that, identify with a degree of clarity or degree of accuracy who that individual is just by their walking patterns. That can be very useful for large access control areas, or in the event of an emergency where you have multiple people evacuating, you don't have time to have everybody scan their badge as they're leaving. You can be able to quickly track people as they're flowing in and out of a space. So that could be just another application of that AI assisted recognition that we were mentioning.
Absolutely. Absolutely. That's a good point and a good application for that as well. If a company has a disaster, they have a fire and they need to vacate the building, how do they know everyone is out? So that's a very good example of how to apply this technology. Autonomous robots is something that we're seeing more and more of. Robotics has been around for a long time, but the ability for it to actually use AI in doing more than just menial tasks is something that is evolving as well. We have an example of this is called cobots, which are collaborative robots, and they work alongside humans to actually do certain things that may require more precision, more strength, or more mundane type activities that humans are not good at. Pressing a button every 3 seconds all day long. Well, humans can do that and certainly have the capability of doing that, but they're not very good at doing that over a long period of time. So, and a couple of other examples of this is Flippy on the left, which is actually a robot that fries French fries. And it takes the material, the fries, and it puts them in. It actually fries them and delivers them to another place. And then it will go as far as to salt or what have you. And these systems are being integrated with like inventory management and things like that, and input management. So it knows when the frozen French fries are getting low, and it orders a replacement or a refill. It also knows when the salt is getting low, and it orders a refill of that. And then that system actually fulfills that and then takes that information and puts it back into the main inventory control system to know when to reorder certain products and things like that. And then on the right we have Chippy, and it's the same type of machine. This one creates, makes, and fries chips and delivers those as well. So a lot of different things that are actually out there right now that are developing even more. And some of the AI is actually developed in, is being used in the cadence. So these machines know when lunch time is and when more people are going to be coming in, and it increases the frequency that it actually does this. Or it may, like for Flippy, it may fry 3 or 4 baskets at one time instead of one to keep up with the demand. So this is one of the AI life cycles. This comes from the AI Risk Management Framework, which is published by NIST, and it can be found on their website. And it's fairly similar to the system or the software development life cycle, the SDLC. It actually takes first of all, the plan. Why do we want this AI, and what do we want it to do? What problem is it going to solve, or what question is it going to answer overall? And it uses the plan and design stage to take all that information in, and then the model is designed and it takes inputs. So this information is pre-programmed or collected, and it processes the data as well, a term that's called data wrangling. We'll talk about that in just a moment. And then it builds the model, and the model is used in a test environment to kind of see what the capabilities are, see if there are any errors and things like that. Once that step is completed, it verify and validate step is kind of built in with the testing to make sure that things are valid, the information is good information, the way that it's solving a problem is correct, the solution is viable, and so it's not, you know, hallucinating or giving some bad outputs. Then the model is deployed and used, and then it enters into the operate and monitor mode. And this is constantly giving feedback back into the build part, or the development model that is maybe in a development environment. So it's learning. Sometimes corrections are needed, and that can be done in real time back to the say version 2 of the model or what have you. And then it can be integrated into an ecosystem. So that full integration comes about through the use and how it is actually interfacing with other AI systems, or it's being used for the particular application of AI, and it's collecting, you know, lessons learned. It's maybe not playing well with another piece of AI, and so those problems have to be solved, and that information gets fed back into the development model.
And we,
yeah, go ahead.
Warren, we see this aligned with, I mean, just look at the ChatGPT deployments. We went ChatGPT 3.0. There were earlier versions before that. It's an iterative deployment. Each time they have a new version, they're working on the prototype. They're taking that prototype, they release it after they do their testing, and then they're using that to form the next iteration, the next release. We go 3.0, 3.5. Now we have ChatGPT 4.0 with its latest version as a paid or premium version, with Chat 3.5 as the open source version. So that's just a clear example of what you just described there.
Right, right. Absolutely, absolutely. This is an AI life cycle. This comes from the IT Modernization Centers of Excellence, and it can be found on GSA's website. But what this does is this takes an abbreviated PDCA life cycle, so the plan, do, check, and act. This is just an abbreviated part of it, where it begins with the design, understanding what the problem is, gathering the data, exploring the data, and doing what they call data wrangling, which is basically just the process of converting the raw data that you have into a usable form. It's sometimes also called data remediation as well. And from the design, it goes into the development. So this is where the modeling happens, and then the evaluation of the modeling. And then it moves into the production environment. Basically, it's deployed and it's monitored. The outputs are monitored and they feed back into the design as well. So something that's interesting as far as the use of AI is the government use of it. So the Government Accountability Office actually did a report which was released on the 12th of December of last year, 2023, and it actually looked at 2022, fiscal year 2022, at what the government planned to do and the uses of AI that the government was going to use. Not surprising, their biggest user is NASA, or the biggest planned user was NASA, and that is true today. But from this report, we actually see that the top two use cases come from NASA and the Department of Commerce, followed by the Department of Energy, Health and Human Services, State Department, etc. So this kind of shows what the planning was for AI, and we're seeing that all come to fruition now. A lot of government applications and government planning is going to be done with AI in the future. So in this first part, we've kind of talked about what AI is at a very high level. Obviously, this is an area that you can really dig deep into and still only be scratching the surface. Now what we'll do in our next webinar is we're going to ask how, and we're going to look at how to audit, both internal and externally, how to audit these systems. And we're going to look at some audit standards. We're going to look at audit programs, the approaches and methods, and the specifics to be able to plan, prepare, perform, and to report an AI audit itself. So that being said, that's the end of part one. Do we have any questions or any comments from anyone? Thank you, Daniel. I see that. Thank you. Any questions, or anyone have any experiences to share with working in AI at this time? No? Dennis, anything that you'd like to add?
I think that was very insightful, Warren. I think that was an excellent presentation. I just want to remind everybody, Warren's our top CISA instructor. So if you are interested in becoming an auditor or getting accredited with your ISACA CISA, sign up for one of our classes at cyberkrafttraining.com. We'll be happy to get you certified here so you can audit not only AI-based systems, but also any type of audit, SOC audits, federal audits, whatever you'd be required to do. But yeah, I really want to thank you, Warren, for putting on such a wonderful presentation. And if anybody has any questions, please be sure. Well, please be sure to join our next part two of the series. And please reach out. Warren and I will be happy to answer any questions you have. Absolutely.
And for attending today, you'll get a continued education credit, as with the last presentation. And Dennis, I think you'll be posting this as well.
Yeah, you can find this at the Cyberkraft Training YouTube channel, also on our Cyberkraft Training LinkedIn page or Facebook page. Any of our social media channels, you'll find this video. So if you need to watch it again, or you're interested in, you missed part of it, we'll be posting the whole video for you.
Absolutely. Absolutely. So again, any questions before we end? No? Okay. Well, thank you everyone who came to the webinar today. I hope this was a value add for you. So Dennis, I'll turn it over to you.
Fantastic. Well, thank you so much, everyone. Have a great day. We'll see you at the next part 2 of the series. Have a wonderful afternoon, and we'll send you your certificate.